I am welcoming you to 10th Science NCERT syllabus as well as the Karnataka state syllabus of 10th standard. Molecular orbitals, lesson 5, hybrid orbitals, sigma and pi bonds. Bonding. Molecular orbitals are formed by in-phase combinations of atomic wave functions, and electrons in these orbitals stabilize the molecule. Antibonding. Molecular orbitals result from out-of-phase combinations of atomic wave functions, and electrons in these orbitals make a molecule less stable. Well friends, a set of orbitals sp2 plus p, this is sigma bond and this is pi bond formation. Bonding molecular orbital BMO and antibonding molecular orbital ABMO. Bonding molecular orbitals are formed by in-phase combinations of atomic wave functions, as I told you, and electrons in these orbitals stabilize the molecule. Excuse me. Antibonding molecular orbitals result from out-of-phase combinations of atomic wave functions, and electrons in these orbitals make a molecule less stable. Molecular orbitals are formed by the overlap of atomic orbitals. The two atomic orbitals combine to form two molecular orbitals called bonding molecular orbitals BMO and antibonding molecular orbitals ABMO. Energy of antibonding orbitals is raised above a parent atomic orbitals that have combined, and the energy of the bonding orbitals is lower than the parent atomic orbitals. Energies of various molecular orbitals for elements hydrogen to nitrogen increase in the order as follows. Different atomic orbitals of one atom combine with those atomic orbitals of the second atom, which have complete energies and proper orientation. Further, if the overlapping is head-on, molecular orbital is called sigma, and if the overlap is lateral, the molecular orbital is pi. The molecular orbitals are filled with electrons according to the same rules as followed for filling up of atomic orbitals. However, the order of filling is not in which of the following molecular sigma 2pz molecular orbitals is filled after 2 pi 2px and 2py molecular orbitals. Well friends, what is hybridization? Hybridization of s orbital, this is blue, and a p orbital, this is p orbital, red of the same atom produces two sp hybrid orbitals, purple, this is purple. So each hybrid orbital is oriented primarily in just one direction. Note that each sp orbital contains one lobe that is significantly larger than the other. The set of two sp orbitals are oriented at 180 degrees, which is consistent with the geometry of two domains. This is 180 degrees. This is linear. The hybridization of s orbital and p orbital rate produces three equivalent sp2 hybrid orbitals. Purple oriented 120 with respect to each other. The remaining unhybridized p orbital is not shown here but is located along the z-axis. This is the higher signs of hybridization. S orbital, p orbital, the extension of atomic structure. The hybridization of an orbital, the structure of C2H6, for example, ethane. If you observe in the ethane molecule C2H6, each carbon has sp3 orbitals. Here, these four orbitals overlap to form 7 sigma bonds. What is meant by hybridization of atomic orbitals? Describe the shapes of sp, sp2 and sp3 hybrid orbitals. Shapes of the orbitals: sp hybridization, sp2 hybridization, sp3 hybridization. Well, this is sp hybridization, which is the linear. Regions of the electron density is 2 here. The arrangement is linear. This is sp hybridization, 180 degree. The bond angle is 180 degree. Coming to the region of electron density is 3. Arrangement is triagonal planar, and this is sp2. Bond angle is 120 degree. The region electron density is 4. This is tetrahedral structure, and this is sp3 hybridization. The bond angle is 109 degree. 109.5 degree is the bond angle. It continues. Triagonal bipyramidal, sp3d hybridization, and this is sp3d2 hybridization. So these are the arrangement of hybridizations. Sigma bond according to orbital concept. What is sigma bond? The sigma bond between two atoms, localization of electron density. Each electron has got its own density. The overlapping of electron density leads to the hybridization. Diatomic molecules, for example, sigma bond and pi bond. According to quantum theory, the molecular orbitals MO of the identical symmetry actually mix or hybridize. As a practical consequence of this mixing diatomic molecules, wave functions S plus S, Pz and plus Pz molecular orbitals become blended here. The molecular orbitals of like symmetry. This is 1s, this is 2p, this is 3d, this is 4f, this is sigma ss, sigma pp, and this is pi pp. So these are the pi bond. For example, in the structure of ethylene, 121.3 degree, the bond length is 133.9 picometer and the 108.7 picometer. Pi bond, this is the pi bond formation, concentrated C2H4. The sp2 hybrid orbitals are purple and the Pz orbital is blue. Formation of sigma bonds, formation of pi bonds. This is the space filling model. Thank you for listening. Let us study the higher chemistry, orbitals and bonding, antibonding and all in the next forthcoming classes, my dear friends. If you like our videos, please don't forget to press bell icon, like, share and